Hello everyone. I'm here again with another text to describe a research paper to retell it based on my understanding. Uh, a quick disclaimer: I am in no expertise in ICU nor nursing, but I am majored in data science, so I try to use the data to analyze it as uh, and try to understand the system overall. So basically what we have here is a research paper by Sarika R. Kope and Susan Elias. The DOI link is written here. You can check it if you want. This is the journal, the Science and Engineering. Okay, so I probably better retelling this in a script type, but then I think it's better to rediscover it instantly while recording. And currently this is 3:40 a.m. So okay, let's do this. Uh, from first of all, the title. The title is about critical correlation of predictors for an efficient risk prediction framework of ICU patient using correlation and transformation of mimicry dataset. So the dataset used is mimicry, and the subject is ICU patient, the subject of research. The what what this research tried to achieve is critical correlation of predictors for an efficient risk prediction framework. And the method is using correlation and transformation of the dataset. So basically, reforming the data or processing the data so uh, it can provide critical correlation of predictors for an efficient risk prediction framework. Uh, Based on my understanding of this title, it probably uh, adjust or transform the data set so it can be used to get a predictor correlation to get an efficient risk prediction for ICU patient. Okay. Uh, at first, when you are looking into research papers, the first thing first when you're reviewing it, of course, you you almost always start with the abstract because the abstract obviously describe everything in subsetted alinea. So uh, yeah, so this is the go-to if you want to uh, do a quick understanding of the research paper. So uh, let's start with abstract, I guess. Various predictive frameworks have evolved over the last decade to facilitate the efficient diagnosis of critical disease in the healthcare sector. Okay, so this is uh, the background setting of this research. Various predictive frameworks have evolved. Okay, so this is the condition right now, and some have been commercialized, while others are still in the research and development stage. An effective early predictive principle must provide more accurate outcomes in complex clinical data and various challenging environments. The open source database system medical information marked for intensive care, or in short MIMIC, simplifies all of the attributes required in predictive analysis in this regard. This database contains clinical and non-clinical information of a patient's stay at a healthcare facility, gathered during their duration of stay, regardless of the number of focused research attempts employing the MIMIC3 database. A simplified and cost-effective computational technique for developing the early analysis of critical problems has not yet been found. Okay, so this is the background setting, basically the urgency or why the author do this research, why the researcher do this research. It's basically, it said that while there are some predictive some predictive frameworks have already evolved and some even already commercialized, but there is no one reliable effective early predictive principle. uh, yeah, a simplified and cost-effective computational technique for developing the early analysis of critical problems has not yet been found. So yeah, the computational technique for developing the early analysis of critical problems has not yet been found. Yeah, uh, based on my some readings too, Mimic3 database is often used for this kind of research too, because it's one, it's open data base, open source database, and two, it's reliable. It also based on hospital real data, and it's already like coded. I forget the terms, but it's already coded, so it's already applied to human research ethic. Yeah, the proposed study focused on the diagnosis and clinical procedures and found distinct variants of independent predictors from the MIMIC3 database and the ICD-9 code. The proposed logic is scripted in Python. Yeah, uh, this is a program that often used in data science and research in data science topic, because it's easy, it's very human to use. It's also easy to code on Python because it really feel very human language, and it really helps a lot of previous language problem, like for example in C you need to uh, make sure you have a semicolon in every line, which is not necessary in Python. And in Java, for example, you need to bracket everything, while in Python you can separate code by only by tab, and so on and so on. And the outcomes of three common machine learning schemes, namely artificial neural network, k-nearest neighbors, and logistic regression. Okay, so three common machine learning. Although it said machine learning here, I think artificial neural networks is more into deep learning, but uh, yeah, k-nearest neighbor and logistic regression. Yes, this is the basics machine learning. Logistic with logistic regression is the base of the basic have been evaluated. Artificial neural network outperform alternative machine learning technique when accuracy is taken into account as the primary performance parameter over the mimicry dataset. Okay, so while I have no I don't think I have enough experience or uh, expertise on this, but this last this last paragraph on of this research paper, uh, should I say, show some uh, a bit of a weakness because as I said before, artificial neural networks is deep learning, while this too is considered machine learning. So this is advanced. You can say advanced machine learning. So when they say the performance outperform, it is to be expected. Although sometimes there is times where logistic regression and k-nearest neighbor outperforms artificial neural networks in some cases, but I think this is to be expected. So maybe we will find the research reason why they choose these three common algorithm in this paper. But yeah, that's what I can comment about that. The keyword is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 keywords. Introduction. The use of science in the healthcare industry has transformed the approach to understanding disease, treatment, patient care, and hospital management planning. Okay, so in the introduction, of course, in paper, if introduction, you need to describe the basically the base of your title. So because this title discuss about ICU patient and risk prediction framework, the researcher need to describe it on the introduction, like the use of this is like the yeah, literally the introduction to their research. The joint science system with healthcare has emerged as a novel model, namely the prospective healthcare model (PHCM). The PHCM is a probabilistic model to predict the possibilities of future medical conditions in advance so that an optimal healthcare plan can be perceived from both the patient and the hospital management perspective, irrespective of the sum of $1.5 trillion per year expenditure for healthcare in the USA. Approximately 40 million Americans lack ready access to healthcare service. Okay, so this is the urgency or the problem. Describe it more. We already see that on the first paragraph, but yeah, introduction also will describe the urgency again of the condition, of the current condition. A critical dimension of healthcare system is balancing a cost burden to the payers as individual or insurers. So yeah, basically in hospital, you you will commonly you will divide it into two categories based on how you pay. First is individual and insurance are in Indonesian language it's asuransi. So ya, asuransi dan individu. The chosen research study is towards building a model of PHCM, prospective healthcare model, to determine the potential risks in advance based on the prospective diagnosis procedure applied to the intensive care unit patient. Okay, so this is the aim of the study, the goal. During critical health conditions, patients are admitted to intensive care units or ICUs to treat various diagnoses, such as admission can either be into one specific ICU or in multiple ICUs to get diagnosed with the specific medical devices. So yeah, basically, during critical health conditions, the patient flow is this is describing the flow of ICU, which a patient with emergency condition will arrive at the ER or the emergency department, or in Indonesia IGD or UGD. So depending on their condition, it might need a specific medical device or sterile places that the patient can be transferred to ICU from the ER or yeah, the emergency department. So basically that's the flow. You get to ER, you wait a doctor to check your conditions, and if your condition if the patient condition uh score or determine dinilai assume no diagnose as ICU necessary, it that patient will be transferred into ICU. Yeah. So yeah, based on the diagnosis, the physician choose a suitable set of procedure for the patients. Yeah. In this process, the physician also needs to find the correlation between the various types of clinical procedure and their anticipated healing outcomes. The retention of patients in the ICU is limited to procedure level. One of the critical requirements from the hospital management perspective and patient well-being is predicting random admission due to risks of complexities after providing specific procedure discharge. So, okay, uh, this this describe this alinea is already trying to focus on uh, one thing that you can predict from ICU patients, which is the readmission. Yeah, basically, from my understanding, the readmission uh can sometimes cost quite a lot. For example, if you are a patient that need ICU, and then um you already got treatment and go home, or already move room, suddenly if your if the patient's condition worsening or the condition met, they they will that patient will need to be readmitted to the ICU room. So several research have already uh, tried to predict readmissions due to yeah the risks of complexities after providing specific procedure and research. To my understanding, this mean in short, they if we can predict the readmission of the patients, we can avoid this and probably make their life expectancy higher. and also be cost effective. Advanced healthcare data acquisition technology acquire various formats of data from multiple dynamic sources over a timeline, and a distributed file system-oriented data models support the intrinsic character like heterogeneity, uncertainty, and high dimensionality of this data. Okay, so this is entering the describe of the need healthcare data technology. Okay, which supported by this sentence. There is a growing trend in data processing and artificial intelligence to build reporting and billing applications in the healthcare industry using this data. Okay, yeah. So basically, people now use data processing and artificial intelligence in order to build uh, a um, helpful model and applications to help healthcare industry in managing or even predicting, like doing some early diagnose. Concurrently, research interests are growing exponentially to build efficient prediction model to provide automatic decision supports to be beneficial for both parents and caretaking personnel. Okay, so yeah, because of that, the research interests are growing. Yeah, because people trying to prove or eventually make one solid models or system that can be directly implemented into a hospital. That is the dream goals of every researcher, I think. However, the research community faces a seamless synchronization between learning tasks and data experience without a flexible, easy to use collaboration between standard access mechanism to the repository and standard processing algorithms. Yeah. Yeah, as we know, collaboration can sometimes be hard because uh yeah, people involved also have different needs and different goals. For example, if you're nursing, you probably will view it on uh, based on the nursing problem more. And if you're a data scientist, probably you will focus on the data more. And usually the research born between the collaboration is split because of the needed scope. So yeah, collaboration is sometimes hard to achieve. A joint initiative of MIT Clinical Inferencing Group, Philips CareView System, Philips Care, and Beth Israel Deaconess Medical Centers, as in Fig 1, has established a project under NIBIB to collect comprehensive data of intensive care unit and produce as mimic datasets. Mimic provides critical data. Okay, so this is the uh, basic description of what mimics dataset contain. This is mimic 3. I believe these datasets you can also try to access from Visionet, but before that you will need a certification for able of human research, and I think signing some digital agreements from Visionet to access the data, but it is open source data, and it is reliable data that already been used many times by the researcher. So yeah, okay, continue on. It records the patient ICU admission till patient discharge. The acquired data are continuous to the related events. It includes demographic, administrative, physiologic, medication, test lab, research summaries. Okay, this is the continuation of the mimic dataset description. The authority script updates. Okay, basically this is telling the update of the mimic 3 and until now. Okay, the main highlights of this research paper are the challenge of obtaining the goal feature factor and identifying the dependencies of variables with potential correlation on the fast varied mimic 3 dataset for designing an ML based predictive model to visualize the insights of the hidden knowledge for a specific patient with their procedure and associated risks. The explicit benefit of feature engineering overcomes the limitation of the labor-intensive and okay, uh, I I don't I'm not sure what is written here, which of usually overlooks outlier dependency and inequalities. But basically, oh, sorry. Uh, so basically, the sentence it's trying to describe here that the of the main highlights is uh is just justification on why people researchers nowadays, especially in data science, try to build prediction models for mm, hospital needs like this, because yeah, the to overcome the limitations. For example, mm, uh like for example uh in in the in the pandemic time, there is a huge wave of patients into the ER. So the patients sometimes, if there is too many patients on one hospital ER, they will need to wait a lot more than usual to get a doctor attendance to check on them on what to do, on deciding what's the proper procedure for them. So basically, the prediction is already helping on that on that part, on helping deciding and helping manage the patient flow of the hospital. So it's so yeah, um um things that have more time can be achieved with less time and less power, human power needed for effective and efficiency. Yeah. Therefore, particle features engineering builds a base for more effective predictive models with reduced computational complexities. Section 2 highlights some contribution towards building predictive models and their dependencies on the feature engineering process. Session 3, okay, so this is the um, basically uh, the what the section, yeah, the section of the description of the section, uh summarize the section summary of this paper in short. as we can read. So we're gonna continue. Okay, so you can see 2, 3, 4, 5. I think it said have 6 sections. Yeah, 6 section, and the 6th section is conclusion. Yeah, conclusion is section 6. Okay, entering the section 2 of this research paper. Existing predictive models using the mimicry dataset. Okay, at present, there are various research attempts to develop a predictive model using the mimicry dataset. Yes. According to a recent study conducted by Moore et al. Okay, so basically this is the literative research of previous research uh, that use, I think, yeah, that use mainly mimic dataset. This is the author. Okay, okay, so yeah, okay, yep, this is existing. Yeah, okay, this is existing research. It describes existing research. I think the detail is better to be read proper, uh, read individually. But yeah, this is the literature research of this paper of existing research on how far the research have achieved based on this paper description. Okay, section 3 is the research problem. Here is the identification of the research problem after reviewing existing themes. Okay, so basically after reviewing this previous research, it has been observed that there are approximately less than 20 journals associated with the mimicry dataset implementation published in the recent 5 years in IEEE Expert. A similar trend has also been witnessed for, okay, for you that don't know, IEEE Expert is a site for uh, publishing journal and conference proceeding. Yeah, some conference can be indexed by Scopus, some maybe don't. Okay, so it depends on the conference, but yeah, this is the reputable publisher or publishing space. A similar trend has also been witnessed for other publications. These studies have examined a variety of issues that can arise while diagnosing a specific illness condition. As mimicry is related to critical care information, it is essential to carry out more investigation. The complexities of the mimicry dataset are vastly different compared to another standard healthcare dataset. Although machine learning is one of the dominant forms of the analytical and predictive mechanism used in medical dataset, the range of the study implementation in this regard are quite a few. Okay, so basically, it's saying the research gap from previous research, even considering that deep learning and other related. Okay, so it mentioned deep learning, but I don't know why it doesn't mention it before. Maybe this research categorize machine deep learning as one as machine learning, which is also can, I think, I don't know. Another related predictive operation is significantly known. Applying them will further introduce more complexities in implementation. It is because of the trade-off between explainability and performance. Although deep learning approaches suit well for more extensive data, they will still introduce a dependability issue when it comes to accuracy performance, the model will offer increased accuracy only with the condition of the availability of a larger trained dataset. Yeah, so basically this also describe the common problem of this topic, this kind of research, that yeah, either the data is not enough or the data is not available, and or the data are in balance. So there's more normal data than the unique data, or uh, the condition data. The model will offer increased accuracy only with the condition of the variability of larger trained dataset. Apart from this, such models too cannot comprehend outcomes based on sophisticated training only, and they will always depend on the selection of specific classifiers. Moreover, choosing an appropriate deep learning model itself is a challenging task regarding the accuracy of the critical care dataset. Okay, yeah. Sometimes, yeah, I agree with this sentence. Sometimes we cannot depend on the accuracy score alone, because there is overfitting and underfitting on machine learning and deep learning, which is a condition that basically if you try to um, for example, in artificial neural network, there is an epoch. So basically, on how many times you run the algorithms on learning the data set, at some point you will hit, you won't hit any further um, increase on the accuracy. And if you run it too many, it will, yeah, it will affect the data, it will affect the score, the end score. It will introduce bias to the model, and if the data set is more normal than the condition data, it also will introduce bias, because the machine learn that, for example, if the data is only uh like in 10 scale, 9 uh in 10 scale, 1 out of 10 is abnormal and 9 is normal, the model can predict all as normal and still get a high accuracy, because there is only one abnormal data set. So yeah, that that's why sometimes this accuracy uh, need to be provided more, uh, like for in common, it's usually provided with specificity, uh, and specificity F1 score, AOC under curve, and so on and so on. But basically all that score usually come from the confusion matrix. So people that uh, include the confusion matrix of the dataset, the prediction model is preferred to be, yeah. So it I think it's more transparent if the research paper provide that. But that's just my opinion. Feature engineering is another potential trade-off that has been noticed. Yeah. Uh, Basically, from what my understanding too, data science now, in order to graduate from its degree, need to utilize feature engineering more, while the computer science kit will probably more on the algorithm modification, but data science students usually will mainly focus on the data and maybe even until the visualization of the data. And maybe yeah, until the algorithm too, but no modification and maybe just testing on how the feature engineering achieve what the feature engineering achieve. Okay. However, because of the challenge with deep learning indicated in the previous paragraph, Mimic 3 will need to evolve with a novel feature extraction approach. Yeah, basically it said a modification is needed for Mimic 3. So from what I get, basically it aimed to build a model data that is ready to use to predict uh, to build the risk factor, I think. Yeah, for predict risks, to predict the risks of the ICU framework. Okay. Hence, looking at the points mentioned above, as a research challenge, the proposed system aims to address the concern computationally and cost effectively. The following section discusses the solution introduced by the proposed feature engineering. Okay, this is the two, right? Okay. Oh, this is the three. This is problem. Okay, entering the feature engineering analytical model. Session 4. The ICD-9 codes are the standard to describe the coding in the healthcare sector for different symptoms, disease, injuries, and condition. Table set 1, 5, 12, and so on. Mimic 3 clinical dataset file description. Review table 1 are used as input. Okay, so this is describing the input in the feature engineering process to transform and prepare a dataset for the machine learning model to predict the possibility of risk after undergoing a specific procedures of ICD-9 codes. The correlation between the data is calculated by comparing the result column to the other columns. In this case, we are extracting contextual data. The model is generally built for common diagnosis and procedures. The prevalence of disease and procedures is determined by truncating and counting them. The first three characters of the ICD-9 codes denote a class, whereas the remaining characters denote the precise diagnosis or procedure. In the present study, only the class of diagnosis or procedure is necessary. The commons information is very significant as it is the main factor that decide the probability of secondary infection. Okay. Yeah, this is the it refers to table 1. Yeah, this is the table 1, I think. Yeah. Okay. As I remembered too, because I already seen its template, the mimic dataset template. Yeah, basically it's uh I I cannot say it's raw, but it is some semi-raw data, which where the data set is like, yeah, um more of operational data set. Yeah, and it is still like separated from each other, from which we know that in order to train a machine learning algorithm, you need to uh, solidify or unify, yeah, the data into correlation, and then train it based on that. Okay, yeah, because the machine did at first don't know the correlation between the data. And if you, like, for example, just in, and yeah, you cannot just input everything into the algorithm. It will not provide an efficient and effective result. The metadata structure of the metadata structure of the source data for the predictive learning model (PLM) is defined as a set. The respective columns, significant construct of the PLM built on the dataset mimicry, the schema of the base table, and original table creates a structure with a tuple of arriving a set. Okay, this is basically describing the metadata structure. And I think the type also, a tuple. A tuple is basically an array, a fixed array. Okay, so this is basically just a description of the metadata. Yeah, this is the symbols description too. Admission alpha is mapped as alpha. Okay, yeah, this is the this is the description. This is HTML ID, subject ID. This is the primary key of admission, hospital admission, and subject ID of patients that extracted from the table admission, I think. Yeah. Okay. Still. Okay, so this is describe the condition, and I think, yeah, and describe the important predictors of A. Basically, the conclusion is the complete important prediction of table admission is subject ID, HTMA, hospital admission ID, admit time, discharge time, insurance, religion, marital status, ethnicity. Okay, so why ethnicity and marital status is important predictors? Because basically before machine learning, there is already an effort, on my understanding. There's already an effort on predicting, not predicting, but like on whether how to decide a patient uh, a patient need to be transferred or not, or basically what um yeah, basically like preventive measurements, which is called early warning sign, or in short is EWS. So they use that parameters to decide or if a patient uh is I lost the word. Wait a second. Basically, if the patient is suitable for certain procedure, or what what uh, what is the procedure needed for that patients. It called early warning sign. I think yeah, for ICU transfer too. But it done by manually, and it's scored manually, so yeah, that's why this parameter is here. This is the parameter used on early warning sign too. I think region, marital status, ethnicity. I'm sure uh, an expert of this An expert on nursing can describe it better than me. Okay, this is the continuation description table, which, okay, yeah, it said how it's linked into HTML ID and the data as gender. Yeah. So yeah, the mimicry is, as I said, semi-raw. There are still semi-link that you still need to build into one, and you need to figure it out by yourself, because yeah, it's the point of it. The open source datasets is to be, yeah, to be analyzed and to be researched upon. The table as you states, okay, this is the continuation table. So basically from every table it's decide on what the predators are and what's the link. So basically in dataset you have I forgot the term again, but there is a proxy. I will call it proxy. I'm sorry if the term is wrong, but I will call it that for now. But there is a proxy table in order to connect to table information. So in order to track uh, the moving information, the transfer or upload or download informations from each table. For example, from if there is a customer table and a seller table, there will be a transaction table that bridges this table across. Yeah, so in order to transfer uh, yeah, basically that. The signification data, okay, this is basically the all the tables. Okay. Okay. Yeah, all is connected to HTML ID and subject ID. So yeah, of course, because it's we need to track the admission ID on which patient is first admitted, and the subject ID on for the, yeah, the basic uh, the basic information about the patients. This algorithm entering this correlation and transformation for diagnosed ICD data. Okay, so we're entering the algorithm. This algorithm is responsible for extracting the correlation with the data transformation that is significant for the diagnosis. The, the contextual approach is used for this purpose in order to extract the significant meaning of it. The contextual information is in terms of correlated details concerning the data information. So, okay, this is how the main framework of the algorithm used to extract the correlation with the data transformation. Okay, the converting environment loads the value. Okay, basically from the table by context perspective. Okay, for that is related to book values. Permanent text is a caps long condition to the page. Okay, so further description on the table too. Okay, this is the, yeah, ERD, I think, the relation between the table in mimic. This is admission. Okay, this, yeah, this is also the selected predictors, I think. Okay, patients. This one connects to admission. Cost center, first care unit, last care unit. Okay, so yeah, from ICU stay, it services. Yeah, okay, diagnose. Okay, this is the basically the table relationship diagram. Through the precision of predictors for the mean mapping of the predictors. Okay. 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 ICD-9 code. Okay, we continue here. Code is assigned as 01166, whereas pneumothorax occurs in the patient suffering from tuberculosis. The ICD-9 code gets assigned as 01170. Interestingly, in both ICD-9 codes of the first three characters, okay, blah blah blah. The predictive model design consider only the class of illness rather than the condition. Therefore, the first three ICD-9 codes are considered while preparing the feature factor. The process of feature engineering that is as follow. Okay, this is the research flow in sentences. The professor consideration that consists of three essential attributes: the YDS primary key, table TD and SRT. This is symbol used as shown in figure T. Okay. The idea is to explore the possibilities of secondary complication could be generated by all short ICD-9 codes. Owing to the inclusion of the variants, there are good possibilities of the inclusion of repetition of the same ICD-9 codes. Identifying this number of occurrence repetitive value. Okay. Okay, this is the code. This is the code diagram, box diagram. Therefore, the transformation process is like this: T1 operation, TD output table. This is the output table. So basically, from my understanding, it's describing on how it merges into the output table that will be used into training. Okay. Okay, this is the algorithm responsible for computing the correlation between the parameters. Wait, didn't I just read that too? Data transformation. Okay, this is data for data transformation algorithm, and this is for correlation, I suppose. Yeah, computing the correlation between the predators. Okay. Similarly, data loading. This contains tuberculosis and pneumonia. Okay. It contains row ID. Okay. This is the feature and additional. Okay. The not needed data in order to make the data as efficient as possible while trained. It eliminate the unnecessary thing data from it, if any of this. And this modeling purposes, the model considering assessing risks by considering rare and unique categories of procedure implementation. Thus, figure 7 illustrates the frequency of some predict standard procedures corresponding to the ICD-9 procedure code for an SS value of the PTH. Hence, the probability of complication is less because an alternate sub-procedure could be presented if a particular procedure seems complicated, therefore the procedure threshold filters are both okay. Yeah, and I'm not gonna pretend. I'm not going to even pretend. I think I lack understanding on what is this ICD-9 codes. But from what I read so far, I think ICD-9 code is for the feature extraction process. Yeah, in the both tables. Okay. Okay. Okay, so basically still talking about the table and the link. Representation required execution data. Okay, so basically the needed data from other table that need to be merged into the output table. Yeah, this is the merging. Yeah, from my experience, there is several way, but the common way is either merge, join, or concatenate. Yeah. From the table. Okay, this is the symbol from previous table. So basically, they subset the data and join the data into one big ready table, in which I hope they put the okay. I think yeah, this is the result. I hope it's all. Length of stay, last care, first care. Yeah, yep. I think this is the result from all that. Uh, yeah, from all that process of the table. This is the result. I think. Hopefully it's all until length of stay. Okay. Okay, entering feature extraction, length of stay. Yeah, this is extracted by subtracting emission time from the time of discharge. So yeah, the length of stay of the patient on how long it stayed, age, yeah, date of birth. Okay, so basically on how obtain the new predictor, LOS and age. Okay, as discussed earlier, there is no significant correlation found between risk factors and the time of year. This is due to the mimicry dataset privacy policy. Okay, so yeah, remember when I said mimicry data set is already coded? Yeah, this is one of it because of the privacy policy and human research policy. The age and the year is encoded in certain way. I think you can read it more on how it encoded on Mimic3 repository. But yeah, it encoded, so it doesn't show you the uh, raw or true value of the year. This is to prevent, yeah, the data to protect the data privacy of the patients, which requires that the date of birth that occurs at the present time to be indexed differently, to conceal the original date of birth. Okay, so basically they don't, yeah, they say there is no significant correlation found between risk factors and the time of the year. This is due to the mimicry dataset privacy policy, which requires that the date of birth that occurs at the present time be indexed differently in order to conceal the original date of birth. Yeah, basically the date of birth is encoded, so there is no way to access the actual, like, precise real date of birth. I think even the year encoded until, yeah, you can only assume, like, for example, a person is born between 19 or 95, something like that. Finally, the feature factors include both x number of predictors and y number of responses as in table 8. Sorry. Okay, coding the master data exploration. Okay, so the unified or the output table called master data exploration refers some of the unique categorical variables for insurance, religion, marital status, and ethnicity illustrated in table 9. Okay, coding. Basically, the machine learning or the computer won't understand the string that is provided by categorical data. So we need in feature engineering, we need a process called encoding. Yeah, basically this is the option, the string, okay, which will be encoded usually like this is one, and then oh, okay, so they encoded into 1 2 3 4 5. They encoded into integer, so possibly, to my understanding, this will be encoded to 1 2 3 4 5. Yeah, and gender, they will be encoded to 1 and 2. Yeah, this is 1 2 1. This is the option. I think for pre-processing, before encoding, I think none, which is an empty, I think it's better to be not included or either to be normalized. Okay. Or maybe do some imputation on it to eliminate that value. But I guess if you already encoded in, if the register already encoded it, this none will be also able to be determined. And also, if from my view of point of the data, which is 1 2 1 2 1 2, I think basic basic machine learning like logistic regression cannot effectively handle this data. I predict the accuracy won't be high because this is many categorical data, and I don't think there is any linear correlation between these data, but we will see. Few computational complexities and challenge to adjust the weight varies. Okay. Basically it's said on how we computed the data and scanning process. Okay, so there is a scale process. Scale is basically some algorithm in machine learning require scale, some maybe do not, and it doesn't affect on the accuracy. Scaling is basically so as you can see, there's one and there's like 10,000 here. If the machine trained by this data on some algorithm, it will create a huge gap between this predictor and this predictor, because the huge gap of the data that if you plot it later to visualize it, it will be like one point here and then one extreme point here. So in order to keep it balanced throughout the data set, the data training session, some algorithm need scaling, but I think modern algorithm many do not uh, do not need scaling or even balance. Okay, 16. Okay, so this is basically the feature that is used: gender, HTML, admission ID, insurance, religion, marital status, ethnicity, cost center. Okay, first question unit, last care unit, then substep, previous service, current service, ICD-9, diagnosis code. Okay, I don't as I said before, I don't understand this code, but apparently this is a feature that is extracted from the dataset. And subject ID, each length of stay. Okay, so basically this is the basic feature. The repetition of x where n is 16, so 16. Let's count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Yeah, exactly 16. In the standardization process, the mean value and the standard deviation are computed in equals equation. Okay, so this is the calculation process of the standardization and the standard deviation using this equation. This is the mathematical equation of standard deviation and mean value. Okay. Yeah, this is Indonesia rata-rata. This is SD, standard uh, deviasi standard thing, if I'm mistaken. Okay. So yeah, this is the and I think because this see the and my this is only my opinion and assume that I think they focusly on INN more and use the logistic regression and k-means at the first. I think k-means or KNN KNN to to like compare the outcome. But I think yeah, AN is the main focus because this is the flow that we see. This is the city plot. Okay, so many features. Important scale and the standard scale for sample features. We are well aware that the probability of staying in the ICU is correlated to the likelihood of the stay in the hospital. So it is necessary to ensure the probability. Okay. Before I forget again, yeah, I think sometimes you can also if you're doing um if you're doing pre-processing, you can compare the scale result and the balance data train. Yeah, the scale data train and the balance data train and compare the result if it shows any significant difference that it may or may not affect the outcome of your algorithm. Well, that the probability of staying in the ICU is correlated to the likelihood of total stay in hospital. So it is necessary to ensure the proportionate peaks of the normal distribution of length of stay of the norms in the ICU. Therefore, the patterns of the peak can be observed after applying standard scaling. Even though the data was scaled, when we use standard scaling, we also observe that the relative position of peaks have been distributed on the data. Since Mimic-3 is a probabilistic dataset in our case, such output is not suitable for both a function approximated performance and a domain's perspective. As we can see, when we apply the min-max scalar, okay, so basically this is the method used to scale the min-max, the infamous scalar of the machine learning. The data is scaled at the same time. Relative position of peaks is not disturbed. The distribution makes it suitable for the probabilistic model. Finally, the collected, aggregated, cleaned, transformed, encoded, and scaled data gets ready. Okay, so basically this is the process, and it said the data gets ready. The neural network take this data set. Testing, it said the neural network. Testing and training purposes after some rearrangement. Yeah, so basically, yeah, I think the main the main algorithm is ANN. So in which I finally agree, I think. So yeah, this is the basically what data science research do. Basically more focusing on creating the suitable data model that can be used into the algorithm, and then yeah, testing, of course, testing the performance of the algorithm. Where's the running risks? Then it can handle large data sets. Yes, and in its data set is an research sector with the first layer and which all takes subsequently connect hidden layers. Okay, so this basically how the ANN works with gradient SGD process. Okay, the iterative, the looping. Yep. Okay, this is the model proposed system. Okay, so the NNN consists of 16 input layer, which is the feature, hidden layer 1, hidden layer 2, and hidden output layer 1. uh, so hidden layer have 5 neurons, hidden layer 1 I think have 8. Yeah, have 8, layers, 8 neuron, 5 neuron, and then output layer 1. Okay, so output layer 1 I think because it's like yes, between 1 or 0 output, the predator, the targeted value. Yeah. Okay, this is the min-max scaling. Oh, okay, so this is the density plot after standard scaling, and this is after min-max scaling. Okay, this is the scale loss. Okay, the peak got higher, and oh, this is the length stay scale. Right. Um, okay, this is the figure of the standard scaling and the min-max scaling. Okay. Result and analysis. Okay. The proposed study is implemented in Python, typical environment under the 64. Okay, this is the environment. Because the performance is evaluated using accuracy, precision, recall, and F1 score. Okay, so it's basic basic that will always follow accuracy, because as I said before, accuracy itself cannot really determine the performance. Apart from that, unlike any existing literature, the suggested research is all about measuring risks for a patient suffering from acute disease without including any specific disease conditions. Okay, So this is it describe again the limitation of this research, which will restrict the scope of the study. Yeah, the limitation basically. The strength of the proposed model. Okay, this is strength. Give is that for a given set of critical care data set, the model can effectively compute accuracy in its risk factor associated with a correlation of predictors. The study outcome of the proposed system has been standard machine learning approach of KNN, logistic regression, and ANN. The justification is all that the machines above. Okay, this is they finally provide the justification. In the learning sims have already have a reported contribution towards healthcare analytics and deep learning methods. The drawbacks of deep learning are discussed in this paper's research problem section. As a result, the proposed studies analysis is conducted on the simplified models, which aligns well with the proposed feature engineering in the mimicry dataset. This section discusses the existing process and the comparative outcome obtained. Okay. Can end with 90% accuracy. Okay, I don't see any accuracy here, but it said logistic regression does not outperform KNN, which is to be expected, I think. Yet in the case of NN, we are using sigmoid as the activation function. Okay, activation function of ANN. Sigmoid, I think, is because targeted targeted the targeted data is 1 and 0, because that's why it's sigmoid, if I still remember. But yeah, in ANN there is an activation function. This was chosen because logistic regression performed well on this data and uses the sigmoid function internally. As a result, the greater a significant improvement when ANN is applied. The individual neuron is assigned to both data cluster, and the model performs better than linear regression. This is to be expected. And yeah, oh, this is a logistic regression. Basically, yeah. Yeah. Uh, Technically, when the sigmoid function is so yeah, as I said before, uh, even though this is not my round to discuss, but logistic regression is the base of the basic. It is, yeah. So my prediction is right. This won't outperform KNN, of course INN will outperform KNN. I think this all is to be expected, but I think this research main outcome is the process output table that can be used. It's designed in order to be either implemented or to be researched further by maybe using more advanced algorithm, because yeah, as you said, it's use simplified model and so on and so on. Okay, this is the confusion matrix. Okay, yes. Okay. It's like method result as observed. Okay, in the future, okay, this is the suggestion. In the future, more research must must be conducted to predict when a patient can get the risks and predict the patient mortality using the same dataset. Yeah, basically it's set. Okay, basically they got 19 logistic regression, 92 in KNN, and 94 in AN. Weird. This is precision recall and reference score, but not accuracy. I think we can calculate accuracy here. Calculator. I think it's easy to use Excel. Okay. Oh, it freeze. My God, freeze. Okay. Okay. As I said, I'm not an expertise here, but I think there is so many there is indication of imbalanced data, I think. Okay, there is indication of imbalanced data or on which I cannot comment, but yeah, there's an indication of imbalanced data that one condition is like outshines or overwhelm the other conditions, the normal conditions, I think, or the normal condition are yeah. Basically there's indication of imbalanced data use, okay, but there is not the purpose. This is discussed about novel feature engineering process being carried out of the mimicry dataset. The goal is to extract significant features from the mimicry dataset to develop a suitable machine learning system capable of computing anticipated the feature correlation. Okay, basically the conclusion, in short, scripted in Python, the research outcome shows that NN offers higher accuracy performance than the other standard machine learning systems. Okay. Okay, this is the reference. Okay. I think that's all from this research paper. The main idea, I think, from what I can get, it's this these predictors that I can model upon as refer. I can took this reference to model if any future research maybe are not as not identical, but like this is can be a reference of the predictor, and yeah, this is also can be reference on of the result. Okay, I think that's all I can say and I can tell, and thank you for reading and reviewing this article together with me. Again, quickly disclaimer, I'm not an expert in any shape or form. I'm just here to read and say my thoughts. I'm sure maybe I have some wrong opinion or viewpoint, which I happily receive criticism or correction even. if there is any wrong say. But yeah, before that I apologize. This is just reviewing uh, thesis paper, basically just reading a thesis paper. Yeah, without any intentions, and this is only for educational purposes. I think that's all. Thank you for listening, and see you again in the next video, maybe.